In this video, we're going to be discussing integer exponents. So a little refresher on exponents. Let's first just look at a few examples of taking a number to a power. So right here we have 3 to the second power. Remember, the exponent tells you, and maybe just go back to a little vocab on the right here first. Remember, your exponent is your number that's written above and kind of smaller to your base. So you have your base, and it's being taken to a power. So just remember, your base is that bottom number, the exponent's that top number. So for this first example, we have 3 to the second power, or 3 squared. So what you're going to do is you're going to string 2 3's together, okay, in multiplication. So it's going to be 3 times 3. So that 2 indicates how many 3's we bring together and multiply. And 3 times 3, that just gives me 9. So this step you probably will be doing in your head quite a bit, but I'm just showing it as of right now. 4 to the third power, that means we need to string 3 4's together in multiplication. So 4 times 4 times 4 will give me 64. And the last one, so 2 to the fourth power, so we need to string 4 2's together. So 2 times 2 times 2 times 2, which will give me 16. So remember not to just multiply those numbers together. You got to think about how many of those numbers do I string together, and what is that answer. So this is kind of a lead into negative exponents, which is what we're going to be talking about in this video. And let's take a look at a pattern going from positive exponent down to the negative exponent. So 2 to the third power, well, 2 times 2 times 2, that gives me 8. 2 squared, 2 times 2, that gives me 4. 2 to the 1 power, so just 1, 2, we just have a 2. 2 to the 0 power. Now you might say that 2 to the 0 power is 0, but actually anything to a 0 power is 1. Notice how we have a pattern here. We're dividing by 2 every time. Now 2 to the negative 1 power, and if you notice that pattern, we're dividing by 2 every time. 2 to the negative 1, it's like, well, how many 2's do we string together? But if we followed the pattern and we divided by 2 again, this would give us a half. And again, if we follow the pattern, if we divided by 2, this would give us 1/4. So 2 to the negative 1 does give me a half. 2 to the negative 2 does give me 1/4. And you might be able to guess what 2 to the negative third gives me. That'll give me a 1/8. So how do we do this without making a huge grand table and looking at the pattern? Well, that's what we're going to look at next. So I have a few steps here. So if you have a negative exponent, you were to imagine if you were on top of the numerator. I forgot the little top there. On the top, at least with these problems, you're going to move the base with the exponent on the opposite side of the fraction, and the exponent becomes positive. So let's just take a look at a problem. So right here we have 2 to the negative third power. So step 1, let's imagine if we're on top of the numerator. So imagine you're on top of a fraction, just like that. We're going to move that to the bottom, that 2 to the negative third, but the exponent becomes positive. So on the bottom, we're going to have 2 to the positive third power. And what's left on the top is just a 1. And then 1 over 2 to the third. 2 to the third will just become 2 times 2 times 2 will give me an 8. So 1 over 8. Now 3 to the negative 2 power, again, imagine you were on top of a fraction. We have to move it to the bottom. So that's going to give me a 3 and make that exponent positive to a positive 2. Again, we'll just have a 1 on top. And 3 squared, or 3 to the second power, will give me a 9. So 1 over 9 for that one. Last one here, 4 to the negative third. Again, imagine you're on top of a fraction. I got to move it to the bottom, make the exponent positive. So 4 to the positive third power, with that 1 on top. And 4 to the third power, 4 times 4 times 4, will give me a 64. So 1 over 64. So you might notice that whenever you just have a number to a negative exponent, it kind of turns into a fraction with a 1 on top. So in this section, you're going to see a variety of problems. On the previous slide, we talked about what happens when you have a positive number to a negative exponent. Here we have anything to a 0 power. So these ones are actually really easy. Anything to a 0 power is just going to equal 1. Now that could be a positive number, it could be a negative number, it could be a fraction, or it could be a decimal. So 5 to the 0 power, give me a 1. 4 to the 0 power gives me a 1. 0.8 to the 0 power gives me a 1. So anything to a 0 power will give me 1. Any number, negative number, decimal, or fraction. Here we have some negative numbers to a negative exponent. So it's going to kind of follow along what we did 2 slides ago. So we have a negative 3 to the negative 4th power. So again, imagine if you're on top of a fraction. I need to move that to the bottom. So this is going to be a negative 3 to the positive 4th. So keep that negative 3 negative. The only thing that becomes positive is that exponent. And these ones can get a little tricky. So on the bottom, we have to string 4 negative 3's together. So imagine we have a negative 3 times a negative 3 times a negative 3 times a negative 3. Well, negative 3 times negative 3 will give me positive 9. 9 times negative 3 will give me a negative 27. And then these two together will give me a positive 81. So 1 over 81 for that example. The next one, imagine if you're on top of a fraction again, and we got to move it to the bottom. So 1 over negative 2 to the positive 3. So on the bottom, you have to string 3 negative 2's together, which will give me a negative 8. So you can write it like this, or you could write it like this with a negative in front. That negative can actually go on the top or bottom or in the middle. Doesn't really matter where that negative goes. And the last one here, we have 1 over negative 6 to the positive 2. And negative 6 to the positive 2 power will give me a positive 36. So negative 6 times negative 6. On this slide, so notice the difference between one we just did, that negative number's in parentheses. This one is not. So on the previous slide, we actually took the negative with the number. But on this slide, we're actually going to kind of ignore that negative for a second, because the 3 is the only thing that's being taken to the negative power, not the negative. So what I want to encourage you guys to do is just put a negative on there. So that really just takes care of that negative. Because the only thing that negative in front does is makes our answer negative. And now I just have 3 to the negative 4th. Well, again, pretend you're on top of a fraction, move it to the bottom. So we have a 3 to the positive 4th on the bottom, the 1 on top. Okay, and 3 to the 4th will give me 81. So negative 1 over 81. The next one, again, just put that negative in the front. We're done with that negative. 2 to the negative 3rd, move it to the bottom, make that exponent positive. I have 1 over 2 to the 3rd, which is going to equal a negative 1/8. So 2 times 2 times 2 will give me an 8. The negative 6 to the negative power, again, got that negative up front. Move that to the bottom of the fraction, so I have a 1 over 6 to the 2nd power. So a negative 1 over 36 will be my answer. So when you're looking through these problems, look at, okay, which type does it look like? Does it look like this? Does it look like something like this that we did previously? But just look at your notes. The next thing we're going to get into is simplifying expressions. So once you can simplify numbers with negative exponents, the expressions with variables are pretty much the same idea. So we have an m to the negative 2 power. So we're going to treat it just like the ones we just did a little bit ago. So again, imagine you're on top of a fraction. That's got to move to the bottom. So m, and make that 2 a positive 2. And with a 1 on top. And that is all I actually really need to do. 1 over m squared. Next one here. Pretend you're on the top. You've got to move it to the bottom. So that's going to become 1 over x to the 3rd. So again, just make that exponent positive. And a to the negative 6, Again, move it to the bottom. So that's going to become a 1 over a to the 6. So here's some problems that look a little different. So I'm going to kind of go pretty fast through these because I'm just kind of layering it on. The ones right here are only a little bit different than the ones before. And notice on these ones, the only difference is that we have a coefficient. We have a number in front of that variable. So 2x to the negative 2 power. Now actually, you can think about this as two parts. There's the 2, and you have the x to the negative 2 power. Now we talked about moving what has a negative exponent, and that's true. But we're only going to move the x to the negative 2 power. So again, we're going to imagine like we're on top. That's got to go to the bottom. So that comes x to the positive 2. But the 2 does not have a negative exponent, so we can't move that. So we're going to leave that. 2 over x to the second. For this one, we have the 4, the x to the negative 5. We can only move this to the bottom of the fraction. So this becomes x to the positive 5 on the bottom, and on top is still that 4. Next one here, a negative 4 y to the negative third. Trying to trick you. We have a negative 4 y to the negative third. The negative 4 does not have a negative exponent, so we cannot move that. So, but that y to the negative third, we got to move that. So we have y to the positive third on the bottom. And we'll keep that negative 4 on top, or you can write it like this. However you want to write. Okay, here we go. Anything to a 0 power, even a variable to a 0 power, is just 1. The next one here, we have 3 times x to the 0. Well, x to the 0 is just a 1, so 3 times 1 will give me a 3. And then on the bottom one here, I got 4, a to the 0, b to the 0. A to the 0 is just 1, b to the 0 is just 1. 4 times 1 will just give me 4. So remember, anything to a 0 power is 1. Okay, so now we're going to get into a little more complicated problems. So remember, only things that have a negative exponent are what we can move, in this case, to the bottom of the fraction. So imagine you're on the top. Now the x to the negative 2, the y to the third, there's only one of them that has a negative exponent, and that's the x. So that is the only thing that we can move. So that's going to go on bottom with a positive 2. And the y to the third, since it does not have a negative exponent, that stays on top. Only move what has a negative exponent. So right here, I'm only going to move the b. So a squared is left on top, and b to the 1, or you don't really even need that 1. It can just be a b on the bottom, which is preferred. G to the negative 2, h to the negative 4th. Now they both have a negative exponent, so I actually do need to move both of them. So g to the second power and h to the 4th power is going to go on the bottom. Now I don't have anything left on top, so I'm just going to leave that as a 1. So a few more. I have a 2, x to the negative 2, y to the third. The only thing that has a negative exponent is that, so that's the only thing we need to move. So x to the positive 2 is going to go on the bottom. And what's left on top is the 2 and the y to the third. Looking at this one, the 4, the x, and the y. X and the y, they both have a negative exponent, so that's going to be written on the bottom with positive exponents. And the 4 is left on. All right, so the next few slides, we're going to talk about what happens when we have a negative exponent in the denominator. So you notice how when we look at all the denominators in these problems, they also do have negative exponents. So the whole idea with this section is that if it has a negative exponent, to simplify it, we're just going to move it. So looking at the first example, identify what has a negative exponent. Well, the x does, and the y to the negative third does. So we have to move both of those. So if it's on top, we move it to the bottom. If it's on the bottom, we move it to the top. So let's start this out. The 3 stays. It does not have a negative exponent. Now x to the negative 2 becomes an x to the positive 2 on the bottom. And y to the negative third becomes a y to the positive third on top. And there we have it. Next example, identify what has a negative exponent. I have a y to the negative fourth. I have a z to the negative third. Those are going to be the only two that we're going to move to the opposite side of the fraction. So that 2 and that x to the second will stay. The z will become z to the third on top with positive exponent. And y to the positive fourth will be on the bottom. And the example last example on this slide, the only one that has a negative exponent is that y. So that's the only one that's going to be moved. So we have 5x squared, and then y to the fifth on top, and then a 3 on the bottom. And we will leave that as is. Okay, so a little bit more complicated problems. So again, identify what has a negative exponent. Well, the w does. So does the z. So we have to move those. So I have a 3x to the fourth, z to the positive 1, but you don't really even need that 1 there. On the bottom, I have the 5, the y to the sixth, and then we move that w down, so w to the third will go on the bottom. So x to the negative 2, z to the negative fifth, we will move those. And another thing that I want to identify is that we have a y to the 0. And remember, anything to a 0 power is just 1, but basically when you multiply anything by 1, it just stays itself. It really doesn't do anything. So basically those variables to the 0 power can just drop off. Okay, in math, if it's not needed, we just don't have it there. So we have that 4, that z moved to the top with an exponent of 5, and the x with an exponent of a positive 2. And that is that one. And the last one here is trying to trick you. They have a 3 over 4, but where do these go? Are these guys on the top? Or are they on the bottom? To answer your question, they're actually going to be on top of a fraction. So imagine those are on the top of a fraction. I have to move that x to the negative 2 on the bottom. So 3y to the fifth. And then the 4 is on the bottom, and so will that x with a positive 2. And the last few slides, we're going to be evaluating expressions with 0 and negative exponents. So what we're first going to do is simplify the expression just like we have been doing. All right. So here we have x to the negative 1. So let's imagine we're on top of a fraction. We got to move that. So that becomes 1 over x to the positive 1, or just 1 over x. And then what you're going to do is you're going to take what x equals and plug it right into our new expression. So putting a 2 in for x, we have a 1 over 2. That'll be your answer. So once you simplify, plug in that number, and you should get either a number or a fraction out of it. So we have a y to the negative 2. Again, we got to simplify that expression. So that becomes a 1 over y squared. And then plugging in negative 6 in there. Now careful on these. When you plug in a negative number, let's make sure to always put that in parentheses. So 1 over negative 6 to the second power. That's going to give me a 1 over 36. So negative 6 to the second power, negative 6 times negative 6 will give me a positive 36. And the last one here, a to the negative third. That's going to become 1 over a to the third. Now plugging in 2, I'm going to have 1 over 2 to the third power, which will give me 1 over 8. So 2 to the third power, 2 times 2 times 2 will give me an 8. So a little bit more complicated problems, and I'm going to do a few of these with you guys because I know that you're going to be seeing some on the homework. So I have 10 minus x, and that is to the negative power. So what we're actually going to do is move this entire thing that's in the parentheses to the bottom of a fraction, and then make that exponent positive. So it's going to look something like this. So I'm still going to have that 10 minus x. I'm not going to touch that. But the exponent is going to become a positive 2. Okay, so we treat whatever's in parentheses kind of like a single variable. And we have that 1 on top. Okay. Now, I'm not going to have you multiply this out. What I actually want you to do is just plug that 8 in right away. So I have 1 over 10 minus 8. So 10 minus 8, of course, will give me a 2. So I have 1 over 2 squared. And 2 squared gives me a 4. So 1/4 will be my answer for that one. Likewise for this one, let's think of whatever's in that parentheses like a single variable. That's going to move to the bottom of a fraction. And the exponent's going to become positive. Okay, now plug in that 2 in there. So 2 times 2, when I plug the 2 in. So 1 over 4 squared. And 4 squared, 4 times 4 will give me 16. 1 over 16 for that one. And the last one here, let's take whatever's inside those parentheses, put it to the bottom of the fraction, and make the exponent positive. So plugging in 1 in for s and 2 in for t, I got 1 over 2 times 1 times 2 to the third power. Now 2 times 1 times 2 will give me a 4. And then 4 to the third power, oops, not 4 to the fourth, 4 to the third power will give me a 1 over 64. All right, let's keep going with this. Again, simplify this down. So you have an x to the negative 2, that's going to go to the bottom. So I got 2 over x squared. Y to the 0 is just going to drop off. Okay, anything to a 0 power is just 1. So that really isn't even needed in this problem, even though they have y equals a certain number. Now 2 over x squared, so 2 over 7 squared, or 2 over 49. Next one, move those negative exponent. The bases with a positive exponent will become on the bottom. So 3 over a squared b. I don't need b to the 1. It's not really needed. So then I have 3 over, and when I plug in these numbers, 5 to the second power, and then negative 2. So remember your order of operations. Do your exponents first. So 5 squared will give me 25. And then 25 times negative 2 will give me a negative 50. So negative 3 over 50. And the last one, move those bases with the negative exponents. So we have 6 over x to the third, y. We can have y to the 1 or just the y. And then plugging in our numbers, you got 6 over 3 to the third times 9. 3 to the third will give me 27. And 27 times 9. Let's see, 27 times 9. We'll do a little scratch work here. That gives me a 63. That'd be 18, 243. So 6 over 243. Now that can actually break down as a fraction. Always break down a fraction if you can. I can divide 3 out of top and bottom. So that's going to give me a 2 over, and 243 divided by 3 is going to give me 81. One last problem. So I have 3/4 times a to the negative 2 power. So once again, we're going to take this. We're going to move it to the bottom of a fraction. So 1 over, and it's going to be kind of strange, but just bear with me here, a to the positive 2 power. Now plug in that 4. So we have 1 over 3/4 times 4 to the second power. Evaluate what's in those parentheses first. So 3/4 times 4, 3/4 of 4 is just 3. And I have 3 to the second power. And 3 to the second power will give me a 9. So 1 over 9 for that problem.